Welcome to Questpond's YouTube channel, and what are we doing today? Today we are running through 20 plus important SQL Server interview questions with answers. So in this complete 1 hour of video, I'll be covering normalization, denormalization, OLTP, OLAP, first normal form, second normal form, Char versus Varchar, Char versus NChar, indexes, stored procedures, functions and triggers, and joins and transactions, and so many important questions. And I can tell you, if you go through this 1 hour properly, at least 5 to 10 questions should come from this list, right? And here is also a small gift. If you go and if you share this video on your Facebook or on your Twitter or on your LinkedIn, I'm going to go and give you this SQL Server interview question ebook, which is like 200 plus SQL Server interview question ebook, right? So go ahead and share this video on your Facebook, on your Twitter, or on your LinkedIn, and send us a mail at questpond@questpond.com, and rest assured that you get this beautiful ebook, right? So guys, let us get started with the first question around normalization and denormalization. Explain normalization and explain the benefit of normalization. Now, as I'm answering this question, let me parallelly also talk about some important tips from the interview perspective. Always try to answer to the point. By answering to the point, you are showing your confidence and you are showing that your fundamentals are clear. For example, for this question, I have seen that many candidates talk about first normal form and second normal form and third normal form. Now the question is, what is normalization, and not what are the different types of normalization, right? So please don't hit around the bush. The interviewer out there who is sitting is also delivering some tight deadline projects, and then you come to the interview and start hitting around the bush. He is not going to like it. So let us answer this question. Normalization is a database design technique to remove redundant data or to avoid redundant data. I repeat this answer. Normalization is a database design technique to remove redundant data. The second important tip which I want to give out here is always go prepared for interviews. It is very much possible that you are a hero in your project. You must have performance tuned complex databases, but at the end of the day, when it comes to cracking interviews, you have to say the right technical vocabulary, you have to talk the right answers, you have to express yourself. So always remember, a prepared developer has more chance of getting success in an interview than an unprepared superhero. So always go prepared. Do not think that preparation is a kind of a low thing. It's just saying that, okay, I have the experience, but I need to express myself. And the third important tip is always try to substantiate your answer with some practical examples. For example, for this question out here, I will answer something like this. So first I will start with the theory. So database normalization is a database design technique to remove or to avoid redundant data. So for example, now let us say you have a transaction table, and in the transaction table, let us say you have country data. So in the country data, you can have data like India and then IND or Nepal or NPL. Now IND and India means one and the same thing, right? So this is called as redundant data. So to avoid such kind of redundant data, we use normalization design technique. So when you go and you substantiate your answer with some practical example, that really hits the interviewer with a very positive vibe. Okay, so just to remember these three things as I go ahead with a lot of other questions. Remember these three things. 3 P's I will say. First one, be to the point, point, P, right? The second P, be prepared. Don't assume that you are a hero in your company so you can crack any interview, right? Be prepared. And last one, be practical. Okay. So now the next question what we will take is, how do you implement normalization, right? So the first question was, what is normalization and why do we use it? The second question is, how do we implement normalization? Normalization is implemented by splitting tables. So for example, you can see here this country data was having redundant data, right? So what you do is that you create a master table must be a reference table where you say 1 for India and 2 for Nepal, right? So you can see now there is no IND, there is no NPN and so on, right? And then in your transaction table, you just give the references. So for example, 1 for India, so Shiv 1, PQR 2, and what is 2? 2 is for Nepal. Now we don't have any redundant data. So to implement normalization, we split the tables. One table has the reference data and that reference ID is referenced in the transaction table or in the other table, right? So this is how we implement normalization. Once there is a question on normalization, there is 60 to 70% chance that you will be asked a question on denormalization. So what exactly is denormalization? Denormalization is a database design technique which focuses to improve search performance. If you look at normalization, in normalization our focus was to remove redundant data, while in denormalization our focus is to improve search performance. So in normalization what we do? We split tables in transactions and reference tables or master tables to reduce redundancy. Now, due to splitting of these tables, data has to be fetched from multiple tables. I repeat this. Because in normalization, we split data into separate tables to remove redundancy, we have to fetch data from multiple tables. So SQL query can become very slow. So in denormalization, what we do? We go opposite of normalization. We merge the table. We are okay with having duplicate data, because our goal is to improve search performance. So just putting it very nicely before the interviewer, denormalization is a database technique which focuses on improving search performance. So when we do denormalization, we try to merge tables. We are okay with having duplicate data. Explain OLTP and OLAP. Explain the difference between OLTP versus OLAP. First, let me talk about the full forms. OLTP stands for Online Transaction Processing and OLAP stands for Online Analytical Processing. And again, this question here, the interviewer wants to test that do you understand how to use normalization and denormalization techniques practically? So again, this question is very much connected question with normalization and denormalization database design. When you talk about systems, which have high load, let us say that you have a system, which has millions of inserts, updates and deletes, and also it has users, a lot of users who are doing a read and a select, and you want that all of these things should be faster, it should have high performance, as well as you don't want redundant data. So in such kind of high volume systems, what the database people do is they create two different databases. One database which they term it as the OLTP system, and another database they term it as a OLAP system. So when it comes to inserts, updates and deletes, right, it's all sent to this OLTP system. And when it comes to fetching records or doing analysis or doing reads, right, or doing selects is all done through this OLAP system. A for analytical, T for transaction. Remember that, right? Online transaction processing, online analytical processing. So in case of high systems, right, high intense systems, you cannot do with one database, you create two databases. Now in case of this OLTP system, what you do is that you try to follow normalization. Why? Because here you don't want redundant data, you want to avoid redundant data. In OLAP systems, you want the select to be faster, so here you try to denormalize the database. Here you want that your select performance should be good. And what normally people do is, that is, as soon as the data is inserted into this OLTP system, there is a ETL process, extraction, transformation and loading, or there is a process, I will say rather, which actually goes and fetches this data and puts it into this OLAP system, right? So the interviewer wants to understand that, do you understand that for high intense systems, you have to create two different databases. One database won't do. For example, if you create a database which is using normalization technique, then your selects will be slower. If you create a database with the denormalization techniques, then the redundancy will increase, right? So to balance both of them, we segregate it. We say that inserts, updates and delete users will go to this system, and the users who want to do a select faster, who want to get reports, who wants to do analysis, who wants to see analytical data and dashboards, they will come to the OLAP system. So this user gets a high performance of read, and this user, if he makes any mistakes about duplicate data, that is all handled because you are following normalization, right? So OLTP and OLAP are nothing but, they are systems wherein in the online transaction processing system, we follow normalization. We want to avoid redundancy. While in OLAP system, we denormalize. We want the selects to be faster. Explain first normal form, second normal form, and third normal form. Now this question from the interviewer's perspective is a very, very basic question. It's a very, very basic question. And if someone is not answering this question, it sends a very wrong message to the interviewer. Now what happens is, people who work with databases day and night, they are writing SQL, they are cleaning up data, they are doing performance tuning. So it is very rare that, developers tend to remember definitions, right? So it is very rare that developers will tend to remember these definitions. So I would, suggest everyone, please go prepared for the interview. Do not think that preparation is a low kind of activity. It is an important activity. It is an important process to make sure that you clear the interview. So let us first start with the first normal form. A table is in a first normal form design when the column have atomic values. A database is in a first normal form, or it fulfills first normal form when the columns have atomic values or they do not have repeating groups. So what do you mean by atomic values? Atomic values means, for example, look at this. This is a name column out here. So this is a primary key. This is the name of the person. And in this name of the person, we have the first name. So Shiv is the first name, Hari is the middle name, and Koirala is the surname, right? And what I've done is I have just stuffed them into this column name out here with comma separated. So this is called as repeating groups. So the first normal form says that if your database design is not following first normal form, you can have insert, update and delete anomalies. Anomaly means when you want to do an insert, when you want to do an update, when you want to do a delete, you have to write weird code. Think about it. If I want to go to the second record, Raju, and if I want to go and update the surname, what kind of query I have to write? Let us say that if I want to go and delete the surname, let's say if I want to delete this third record surname, what kind of query I have to write? I have to write weird queries, right? So it leads to very weird insert, update and delete, right? So what the first normal form says is that create different columns, every column should have a single value. So you should be having like first name, you should be having like middle name, and you should be having like last name, right? So atomic value, so that means that Hari goes here and then Koirala goes here like this. So this is called as you are satisfying the first normal form. So it should have atomic values. Second normal form. In second normal form, first, all the rules of first normal form should be followed. Means the table should have atomic values and should not have repeating groups. Second, all non-key columns. For example, here you can see in this table, we have like 4 non-key columns. All non-key columns should be fully dependent on the primary key. So we can see here we have a joint primary key of ID and the country ID. Okay. So first name, yes, it is fully dependent on the key. If this middle name and last name, they are also fully dependent on the key. But look at this country name. The country name is only dependent on this, partially dependent on the country ID. It is not directly connected with the customer. So we already have the country ID and on that it is partially dependent, right? So we should not have any column which is having partial dependency on the key. So what we do out here, we remove this country name and we move it out from here, and because this country ID is already here, right? So in the master table, you already have country ID. So we just move it out here in a master table or something, and we remove the column from there. So we say that a table is in second normal form when there is no non-key column which is partially dependent on the primary key. It should be fully dependent on the primary key. Third normal form. In third normal form, first thing, the table should satisfy all the first normal form and second normal form. In third normal form, we should not have any transient dependency. Transient dependency means there should not be any non-key column which should depend indirectly on a other non-key column. For example, you can see here, this is the customer list, and it says that this customer has bought shoes, shirts and shoes. Now every product has a cost. Now that cost is also here in this table. Now this per product cost is dependent on this product out here. This non-key column's value is dependent on this non-key column's value, right? So this is a transient dependency. Now what should really happen out here? You should have a product master, right, somewhere, and there you should have the cost and the size of the product, whatever it is, right? So we'll say here, okay, shoes is 10 and shirts is 20, right? Extra large or whatever, size of 8 and so on. And then we don't need it here, right? So when we say, okay, shoes, we look up here and we get the cost. So there should not be any transient dependency of non-key column on the other non-key column. So in other words, putting forward a complete answer, you can remember this word apt. Apt. Remember, in interview, sometimes you can use acronyms to remember things. Apt. Apt means appropriate. A for atomic values. All the columns, should have atomic values. We should not have repeating groups. P, partial dependency. Partial dependency means, we should not have any non-key column which is partially dependent on the primary key. And finally, T, transient dependency. We should not have any non-key column which is dependent on another non-key column, right? It is apt. Apt means appropriate. It is apt to use apt to get a job. Everything is fair in getting a job and war, right? So remember this word apt, and always remember that for such kind of questions, right, these words like transient, partial dependency, atomic, non-repeating groups, anomalies, it's very difficult to remember them. So I would suggest, please go ahead, put down your answers in a Excel somewhere, right, or in a Word document, and just revise them. There is no shame or there is no low thinking, to revise something, right? So use good technical vocabularies like atomic, transient, partial dependencies, anomalies, right, to answer this question, right? So again, I repeat the answer: atomic, partial dependency and transient. What is the difference between a primary key and a unique key? First thing, primary key and unique key, they ensure that we do not have duplicate values. So in other words, for example, you can see here in this table, we have this ID, which is a primary key. We have this social security number, which is a unique key. So both of them do not allow duplicates. If you try to put a duplicate here, you will get an exception saying that unique key error. If you try to put a duplicate here, you will see that there is a primary key error, right? So duplicates are not allowed in both the columns. But now, what is the big difference, right? The big difference are the two ends. So when you are answering this question in the interview, start with the two ends. The first N is nulls. In unique key, you can put nulls. For example, in social security number, I can put a null, right? But in case of a primary key, I can't put a null. So point number one, primary key cannot have nulls while unique key can have nulls. The second N is the number. You can have one or many unique keys. For example, here you can see here, social security number is a unique key, email address is a unique key, but in a table, you can have only one primary key. So for example, here I have just one primary key. I cannot create multiple primary keys out here. You can see here, this is a primary key. If I try to go and create a primary key here, if I try, the first one goes off. You can see this key has gone down, right? So you can have only one primary key, but you can have many unique keys. So first thing, for this question, hit the two ends, nulls and numbers. Nulls, in unique key you can have nulls, while in terms of numbers you can have many unique keys in a table, but you can have only one primary key. What's the difference between char and varchar? So from the interviewer's perspective, right, the first sentence which should come out is char is fixed length while varchar is variable length. That is the first thing, right? Now let us try to put more explanation around this. You can see here I have country code which is char of 3 and I have country name which is varchar of 10, right? Now when you define a data type with char, irrespective what data you put, it will always take 3 characters or whatever is the character length. For example, here you can see I have put ind, it took 3 character length, 3 length. I have put npl 3 length, but look at this. Now this is only 2 characters US, but still he has taken 3 characters. So when you say char, it is fixed length irrespective. And second, also for char you cannot put 4 characters because the size is 3. So you can't really expand dynamically as well, right? So it is fixed length, absolutely fixed. But now look at varchar. You can see in varchar, the length is 10, but depending on the data size, it will vary. For example, for India, it took 5 characters. For Nepal, it took 5 characters. For America, it took 7 characters. So it is variable. So the length is 10, but depending on the data size, it can adjust, right? So char is fixed length while varchar is variable length. Differentiate between nchar and char. Differentiate between nvarchar and varchar. Differentiate between text and ntext. This n in all of these data types, stands for Unicode. Or in simple words, if you want to store non-English characters as well, right? That's where we need this n. This n stands for internalization, right? So if you want to store pure English characters like A to Z and capital A to Z and small a to Z and 0 to 9, then you can use char. But if you want to store non-English characters like Chinese, Hindi, Tamil, Malayalam, Nepalese languages and so on, then you need to use n, right? And the time you say nchar, right, this word n when it comes in, for one character, it will take 2 bytes because you have to support now Unicode. While when you just say char, so the time you say nchar, it is 2 bytes. For one characters, it will be 2 bytes, right? And when you just say pure ASCII, that is non-Unicode, then for one character, it will take 1 byte. So if you see here, this country code is nchar, while currency code is char. So country code here, it is just 3 characters, but it has taken 6 bytes. Look at currency code, 3 characters, but it has taken only 3 bytes. So remember that, yes, when you use n, you can store non-English characters, but at the same time, the size also increases. So the difference between char and nchar is nchar helps you to store non-English characters or Unicode characters, while char helps you to only store pure English characters and 0 to 9 numbers and so on. And the time you say nchar or nvarchar or ntext, for one character, it will take 2 bytes. What is the use of index in SQL Server? So let's answer to the point. Remember the 3 P's, answer to the point, be practical and be prepared. So indexes helps you to increase the SQL Server search performance. So when you say you want to go ahead and increase the select performance or the search performance, right? Indexes is your friend, right? So for example, now you can see here, let us say that you have these records in SQL Server 1, 2, 3, 4, 5, 6 till 99 and 100. So let us say if you don't have an index, then it will do a sequential search, right? It will start like 1, 2, 3. So let us say you want to locate 99, it will go sequentially until it locates 99. So that is quite performance intensive. So what happens is when you create an index, it creates nodes and leaf nodes and so on, right? So it creates a B tree structure, a balanced tree structure. So what happens is when you go and you create an index, it will go ahead, it will create a node here. For example, this node says, okay, less than 50, right? And there is one more node here must be, which is more than 50. I'm sorry, this is 50, right? So this less than 50 covers from here till 50. and more than 50 covers from here till 50. Remember that in actual practice, you can have lot of nodes and leaf nodes. At this moment, I've just created one level of node, right? So now what happens when an end user says, I want to go and search for, let us say 52 or 54. So he will say, okay, is 52 greater than 50? He will say yes. So it will start from searching here. So let us say you are searching 52. Is 52 greater than 50? It goes here. In short, it completely now does not scan from 1 to 50. It bypasses all these records. It goes here 51 and says 52 and it locates the record, right? So rather than going and scanning all this right away, because of the structure, because of the node and the leaf nodes, so this is termed as a leaf node and this is termed as a node, right? Because of this B tree structure, this balanced tree structure, your search performance has improved, right? What you can also do is, during the interview, you can give an example of an index of a book. So for example, if you look at a book, right, in a book, let us say you want to locate chapter 20. Okay. So for chapter 20, how do you do it? You will look at the index. In the index, you will say, okay, this is chapter 20 on page number 100, and you will go straight forward to page number 100. So must be when you're giving this answer, you can give the example of a book to make it easy for the interviewer to understand, right? So what is the use of index? Index helps you to increase your search performance. How does it do it? It does by creating nodes and leaf nodes. It creates a balanced tree structure, and because of that, it can locate the records faster. What are the two types of indexes? There are two types of indexes in SQL Server. One is the clustered index and another one is the non-clustered index. What is the difference between a clustered index and a non-clustered index? First thing, any index, either it is a clustered index or either it is a non-clustered index, they will have a B tree, a balanced tree. So you can see here, this is a clustered index which is on an ID, right? This is a clustered index which is on an invoice number, right? So when you create any index, there will be a balanced tree structure. In case of clustered index, the leaf node will point towards the actual data. So you can see this is a cluster index which is on an ID column, and this is the leaf node, right? In this case of non-cluster index, this is the leaf node, right? So the leaf node of the cluster index points towards the actual data, right? The actual record, right? But in case of non-cluster index, the leaf node point towards the clustered index. So it uses the clustered index nodes to further go and locate the data, right? I again repeat, in clustered indexes, first thing, both in clustered and non-clustered indexes, they will have a leaf node like this one here is the leaf node of this non-clustered index of invoice number. This one here is a leaf node of the clustered index of ID. So both non-clustered and clustered index will have a B tree structure, right? Balanced tree structure. In case of cluster index, the leaf node will point towards the actual data, but in case of non-cluster index, the leaf node will take help of the cluster index nodes later to locate the data, right? That's why, you can have only one cluster index and many non-cluster indexes. Because in case of cluster index, you can point towards the data in only one way. That's why you can have only one cluster index and you can have many non-cluster index, right? Again, answer to the point, both cluster indexes and non-cluster indexes will have a B tree structure. The cluster index leaf node points towards the actual data, right? While the non-cluster index leaf node takes the help of the cluster index to points towards the data. And there can be only one cluster index and there can be many non-cluster indexes. What is the difference between a function and a stored procedure? Now, whenever you are set to compare two entities, always first talk about the main difference. First talk about the goal, the core thing, why that entity exists, and then start with smaller things. For example, many developers, what they do, if you say to compare two things like function and stored procedures, They will start with something saying that, okay, function can be called in a select and stored procedures cannot be called in a select. These are small things. Start with the main goal, hit with the main goal, and then start talking about other things, right? So let us start here. What is the difference between a function and stored procedure? The whole goal of function is to get computed values, to do computation. So for example, you have an interest calculation function, or you have some kind of a function which does a count and a sum and an average, right? That kind of a function, right? So its main thing is computation. And because the main theme is computation, right? In functions, you cannot do inserts, updates, and deletes. You cannot make permanent changes to the environment. So any kind of permanent changes to SQL Server, you can't do by using functions, because the whole goal is to get computations. While when you talk about stored procedure, it's almost like a program. It's like a mini program which can change the environment, which can do inserts, which can do updates, which can do deletes. It can go and it can drop a database, and it can do anything and everything within SQL Server. So it's like a mini batch program. Once we have spoken about the goal, now we can talk about the byproducts. Now we can talk about the brownie points, or I will say now we can talk about the low-hanging fruits. So the next thing is execution. You can execute a function, from many places, because the goal of function is to reuse some computation logic. So it has some computation logic, and you want to call that from multiple places. So that's why a function can be called from a select. It can be called from a where clause. It can be called, from another stored procedure. But when you talk about stored procedure, it's like a mini batch program. So it cannot be executed from a select or a where clause, or even from a function. You cannot call a stored procedure. A stored procedure can be called, directly from the environment. For example, it can be called from a C# code. It can be called from directly from SQL Server writing execute, but it cannot be reused at a mini level, because it's a program by itself, right? So it cannot be called in a select or a where clause or from other functions and so on. And the last one is the output, right? So when you talk about functions, right, you can have a single value, you can have a multiple table valued function as well. And in case of stored procedure also, you can have a single or multiple outputs. But mostly if you see, right, in functions, mostly developers use functions, to return scalar values. So I call a function and then I want to get a single value. So most of the time functions are used to get some computed scalar values out, right? As I've said, again, you can have multiple sets of output from a function as well, but mostly it is used for scalar values. So remember, the main goal, function is for computation, and because it is for computation, it does not make any kind of permanent changes to the environment. While when you talk about stored procedures, it is a mini batch program. It can change the environment. It can do inserts, updates, and deletes. This computation logic, can be reused, in a select, in a where clause, or called from other stored procedure. But when it comes to stored procedures, it cannot be used in a select or a where clause. And mostly functions are used to return a scalar value. You can return a set value, but most of the time, they are used to return a scalar value. So these are some of the important points you can highlight while you are answering this question. Also, I'm flashing one or two one-liners at the top which you can remember while you're answering this question. What are triggers in SQL Server? Triggers are nothing but they are small piece of logic which you want to execute when certain events like insert, update, or delete, or any other events happen. And once those events happen, you want to go and execute that logic. So you can see here, this is a very simple trigger out here. It says that when any insert, update, or delete happens on the TBL customer, go and make an insert into the audit table with the current date and time. So you can see here, as soon as any insert, update, and delete happens on TBL customer, this trigger will fire and it will make an insert into the audit table with the current date and time, right? So you can see here right away here, this is the logic. So now if you go to this TBL customer, right, and let us say I go and I delete something, I go and I delete this thing out here. So at the back end now, the trigger would have fired. So if I go to my audit table, it will show me that this last updated time. So if I go and if I modify something like this, if I go here again it will make an entry over here. So you can see this again, an entry is made here, right? So trigger is nothing but small piece of logic, which you want to execute when insert, update, delete, or a lot of other events like even login and log off and some other events also you can track and execute triggers. What are the two different types of triggers? There are two different types of triggers in SQL Server. One is the after trigger and one is the instead of trigger. So after trigger is the trigger which fires after the event has happened. Means, for example, after the insert has happened, this insert to TBL audit logic will get executed. After the delete has happened, after the update has happened. But we also have something called as instead of. Instead of trigger fires instead of insert, means the insert, delete and updates don't get executed, but instead of these these DML statements, your logic gets executed. So for example, you can see here, I'm going to go and execute this. I have just changed the after trigger to instead of, right? So now what will happen is, if I go to my TBL customer and if I change something, for example, I'm changing this to QQQQ to, let's say, Shiv. You can see it did not change it. It did not update it. But instead of that, it executed this trigger. Again, I can show that. So if I change this to test, nothing happens. But instead of that, it fires the audit table. If I go and if I delete it, the delete will not get executed, right? The delete has not got executed. Instead of that, so if you can see, you must be thinking it has deleted. No, if you try to edit it back again, you can see that record still exists. So there are two types of triggers. One is the after trigger, right, which happens after the insert, update, delete or any DML statement happens, and one is the instead of trigger, which fires instead of the insert, delete and update. What exactly is an identity column in SQL Server? An identity column, so if you see in SQL Server, when you select any numeric data type, you get something here called as an identity specification. So what exactly is this identity specification? When you define a column as identity specification as yes, the values increment automatically. So it is an auto incremented column by SQL Server. So for example, you can see on this TBL customer, this ID is auto increment, and you can see now it is disabled. I can't put values myself out here, right? It will be automatically incremented from 11 to 12 and from 12 to 13. So for example, if I put a value here that is 12, it is 13, it is 14, right? So an identity specification is an auto incremented column. And the goal of this auto incremented column, you can see that some values are coming as null, but don't worry, I'll just re-edit it again. I'm sure that the values are there, right? So it is an auto increment column which is automatically incremented by SQL Server. What exactly is a transaction and how can we implement the same in SQL Server? Transaction helps us to treat a series of activities as one logical unit, right? So for example, you can see here, I'm inserting into table, inserting into TBL customer, Shiv1, Shiv2, probably I can do some more activities here like delete, or I can do an update, or I can do something else, right? So you can see here we have series of activity which is happening, insert, 2 inserts, 1 delete, must be 1 update. So all of these series of activity, it will treat as one single unit. One single unit means either all of these activities will commit or either all of these activities will roll back. So in other words, either all of them are successful. If any one of them is not successful, then everything will get rolled back, right? So for example, now if you see, I have opened up a transaction here. This is how you write a transaction in SQL Server. You will say begin trans and then you will say commit trans. In case if there is any issue, in case if there is any error, you can see I have written a try catch, right? And in the catch, I have rolled back. So if there is any error, I want everything to be rolled back. So I'm going to go and execute this. So you can see 1 row affected, 1 row affected. So 2 rows are affected. And if I go out here and if I just select, you can see both Shiv1 and Shiv2 have committed successfully, right? Now let me go and delete this. Now let me go and put some bug out here. So this first name, has 20 characters. What I will do is I will go and I will add more than 20. So you can see here I've added more than 20 characters. So once I've added more than 20 characters, this value will not be saved into database, right? This first statement will be successful, but the second statement won't be successful. So in the second statement, what it will do is it will come to this rollback. It will come to this catch block and it will roll back, and it will roll back even Shiv1. So Shiv1 will also not get saved, even though Shiv1 has been successful, but because we have said begin trans and commit trans, it would roll back, right? So I'm going to go and execute this, and you can see here 0 rows affected. So it made an insert. So this one row affected was this one, but later on there was error out here, and because of that error he just rolled back and it said that in total 0 rows have been affected. So if I go and if I make a select here, Shiv1 and also whatever that Shiv2, both have not been saved successfully, right? So transaction means it treats a series of activity as one logical unit. Either all of them is successful or either all of them fails. I repeat this. Whenever you are answering this question in the interview, please make it very simple and clear. Transaction helps us to treat series of activity as one logical unit wherein either all the activities are saved successfully or all of them are rolled back. And how do you implement transaction? By using begin trans, commit trans and rollback. Now I want to make a very strong statement here. I will stop teaching SQL Server if you come across any SQL Server interview where you were not asked question around writing SQLs, writing complex SQLs. And specifically questions around joins. Joins are the most sorted one. And if you're not able to answer questions on SQL writing or like inner join, left join, right join, full outer join and cross join, your SQL Server interview is not going to be successful. So let us quickly go and revise what exactly is the inner join, left join, right join, full outer join and cross join. I also want to make a very strong statement out here, specifically for people who are like freshers or 1 or 2 years of experience, right? Even for seniors, I would suggest this is very much valid. Many times, the interviewer will tell you to write SQL and your basic structure of SQL should not go wrong. Sometimes think about it. You are told to write inner join and you don't know how to write it. It will send a message to the interviewer that you do not know SQL writing and your interview is not continuing ahead. It sends a very bad message that you are not able to write SQL, right? So first thing, let us go and get started with inner join. What exactly is an inner join? Inner join selects matching records from both the tables. Look at my answer, straightforward to the point. When you make an inner join between two tables, it will select the matching records. For example, you can see here, there is this TBL customer and this TBL customer is having a reference of country ID from the MST country table, right? So if you want to go and select matching records, then we will say here select star from TBL customer. Now look at this. You can see that how I am hands-on in SQL writing. So here you need to be a little bit careful that you don't make silly mistakes, right? So inner join on inner join MST country on TBL customer dot country ID and match it with MS3 country dot country ID. And I will say that I want to select only the name of the customer, right? The first name from here, right? So I would like to go and select the first name, and from here I would like to go and select the country code, right? Country code. So let me execute this. So if you see here, if you see the output, right, it has only selected Raju and Raja because the test and ABC have nulls as a reference. So only the matching records. So Raju is having country ID which is mapping, so matching. So he has pulled up IND, he has pulled up NPL, but he has not pulled up other countries which is USA or UK, right? So basically when you say that you want to go and select only matching records, then you will use a inner join. Now let's talk about left join. So in case of left join, so the same statement, I will just make it left out here. When I say left join means left table. If you see at this moment, wherever I'm sitting right from there, this is the left table and this is the right table. This is the left table, this is the right table. I am looking from the side of the laptop, from the computer. This is the left table towards the monitor. This is the left table and this is the right table, right? So when you say a left join, all the records from the TBL customer will be selected, from the left table will be selected, and only the matching records from the MST country will be selected. So if MST country has any kind of unmatching records, those won't be selected. So if you see here, if I execute this, you can see that this MST country also has some, so let me do a select star from MST country. So if you see here, this MST country also has USA and UK. So for USA and UK, we do not have any matching entries. So you can see here what he has done. He has only selected NPL and IND. But the test and ABC, if you remember, do not have any matching records, still they are selected. So all the records from the left table will be selected and only matching records from the right table. And when you say right join, that means from the right table, all the records will be selected and from the left table only matching one. So you can see here, now only Raja and Raju is seen out here, but from the country table, even things which are unmatching is also selected. Then we have the full outer join. In case of a full outer join, if you look at the output of full outer join, all the matching, unmatching records from the left table and all the unmatching and matching records from the right table, both of them are selected. For example, you can see Raju, it is matching with NPL. So yes, Raju has a country code of IND, but for test and ABC, there is nothing. He has given out null here. For USA and UK, there is nothing. So the first name is null. So when you say full outer join, all matching, unmatching records of both the tables are selected. And then we come finally to cross join. Cross join is nothing but a Cartesian product, right? So when you do a cross join, you cannot use the on clause, because cross join means every record of the customer table will be mapped to the MST country. So every record will be Cartesian or multiplied with the MST country. So here, if you try to use an on clause, you can see it is saying incorrect syntax, because in cross join we will not have a criteria as such. There is no matching criteria. It is just a Cartesian product. So you can see here, Raju, he has made an entry with IND. Raja, he has again said IND, test IND. Raju with NPL, Raju with USA, Raju with UK. So every record of the customer table is joined with every record of MST underscore country. So this is called as the Cartesian product. So very quickly wrapping up, inner joins, only matching records. Left join, all the records from the left table and only matching records from the right table. Right join, opposite of left join, from the right table, all the matching, all the records, and from left table, only matching. Full outer join, matching and unmatching records from both the tables. And finally, cross join, it is a Cartesian product which takes every record of the left table and multiplies it with the right table. Okay, so congratulations, kudos and congratulations to you, and congratulations to me as well. To you because you completed this 1 hour video series, and to me because I created this 1 hour video series, right? Now this was part 1. So what we will do in part 2 and part 3, we will focus on SQL query writing. When you talk about any SQL Server interview, if you are not good in SQL query writing, your interview is not continuing ahead, right? So the coming part 2 and part 3, which is like 30 minutes of video, we will focus on SQL query writing. Part 4, we'll talk about views and so on. So this complete SQL Server interview question video series continues, right? And now the remaining parts, are available on questpond.com. So you can either go to questpond.com and get access to the remaining parts, or else you can go to the YouTube membership area. So down below, you can see that there is a join button, and also you can see on the on the description, there is a YouTube membership area where you get access to this SQL Server interview questions, right? And MSBI interview questions and MVC and .NET and C# and Angular and so many interview questions out there, right? So hope you have enjoyed this video. And very quickly before I sign off, remember, if you go and if you share this video on your Facebook, on your Twitter, you get access to this beautiful 200+ interview question ebook. So go ahead, share this video link and get access to this SQL Server interview question ebook. Once you share the video, you have to send us a mail at questbond@questbond.com, right? So thank you very much. Happy learning, happy job hunting. I hope that you land up into a nice job, you get nice packages, and hope that you and your family stay happy. Thank you.